Alright, thanks for watching. And does it ever make you upset when your non-mathematician friends say things like 2.01 times 2.99, well, that's roughly equal to 2 times 3? Then this video is for you because today I will show that the 4 basic operations are continuous. And what do I mean by that? I want to show first of all, claim 1, that if you consider the function f from R2 to R2, from R2 to R, where f of xy is just x plus y, I want to show that f is continuous. And just so that our notation is clear, for points in R2, I denote the distance by double bars. So for instance, the distance between xy and x0, y0, I'll write it with double bars, and that's square root of x minus x0 squared plus y minus y0 squared. But usual distances in R, I'll write them with absolute values. B minus A, distance between B and A. Okay, now what do we want to show? So first of all, to show it's continuous, show that f is continuous at the point x0, y0. Okay, now let epsilon be given. Well, and let delta be epsilon over 2. And you'll see why, because we'll have 2 pieces. Then, if the distance, again, x comma y minus x0 comma y0 is less than delta, which again, remember, is epsilon over 2, then notice the following. In particular, x minus x0 is smaller than that distance. So then, if you take the distance between x and x0, well, that is less than square root of the distance between x minus x0 squared, but then this is less than or equal to x minus x0 squared plus y minus y0 squared. Because you're just adding a non-negative term, and by definition, this is less than epsilon over 2. And well, you can play the same spiel and you get y minus y0 is also less than epsilon over 2. Now, why does that help? Because then take the difference between f of xy and f of x0 comma y0. Okay? And then that is equal to, or that equals to, y plus x plus y minus x0 plus y0. But then you can just write this as x minus x0 plus y minus y0. And then you can just use the triangle inequality. So that's less than or equal to x minus x0 plus y minus y0, but less than epsilon over 2 plus epsilon over 2, and that's epsilon. Wow! So that's why it makes sense to say something like 1.01 plus 0.999 is roughly 1 plus 1, which is 2. And not 1 plus 1 equals 3, as I wrote in one of my videos once. Okay, very good. And in fact, I want to give you, before I move on, a really cool application of this. So, application. In another video, I've shown that if f and g from R plus R, R to R, are continuous, then f plus g, or let's say like this, if f1 and f2 from R plus to R are continuous, then f1 plus f2 is continuous. And before I did it, just directly, but now here's the awesome proof. Well, first of all, since f1 and f2 are continuous, we get that f1 comma f2. So the pair is continuous. And this I've shown in another video. I've shown that a pair is continuous if and only if each component is continuous. But now, compose this with the addition function. And so, since we've just shown the addition function is continuous, the composition is continuous. So again, this is continuous by this fact, this is continuous by what we've shown, so the composition is continuous. But what is the composition of the pair with the addition function? That's just f1 plus f2. Because f, what it does, it adds the first component to the second component. So this is continuous. So super quick proof that the addition of two functions is continuous. How cool is that? All right, and now let's move on. Let's prove it with subtraction. So claim 2. Let's show that f, again from R to R, and from R2 to R, where f of xy is x minus y is continuous. Y minus x doesn't matter really. And so same thing as before, so let's show it's continuous at x naught and y naught. So let epsilon be given and let delta be epsilon over 2. Then if, again, the length of x and y minus x naught y naught is less than delta, which is epsilon over 2, then again by the same spiel, x minus x naught is less than epsilon over 2, and y minus y naught is less than epsilon over 2. But then the distance between f xy and f x naught y naught, this time this becomes x minus y minus x naught minus y naught, and that is x minus x naught, and then plus, or if you want minus y naught, because y naught, and that's less than or equal to x minus x naught plus y minus y naught, but it's less than epsilon over 2 plus epsilon over 2, and that's epsilon. And therefore also subtraction is continuous. And now let's move on to multiplication. And by the way, I know there are easier ways of doing this, but the point is all those methods are very direct. So that's for direct people, if you want. Directed by me. So consider now f from R2 to R, and f of x comma y is xy. Okay, I want to show that now multiplication is continuous, which answers the question at the very beginning. So, and for this, let's do a little bit of scratch work, because it's not too obvious. So what we want to do, we want to estimate f of xy minus f of x naught y naught. Okay. But that's just xy minus x naught y naught. But then here's a nice trick as usual. Let's add and subtract, let's say xy naught minus xy naught plus xy naught minus x naught y naught. Doesn't matter which one you add or subtract. But here the nice thing is, this is less than or equal to x times xy minus xy naught plus xy naught minus x naught y naught. So again, here we added this magical term, and we use the triangle inequality, but now notice, here this x is a common factor, and here y naught is a common factor. So we get x times y minus y naught plus y naught times x minus x naught. So now we know this is small and this is small, so we just really need to control this, because this is pretty much constant. But now notice, just as usual, if, let's say, the distance, or if the distance between x and y and x naught y naught, let's say if this distance is less than 1, then in particular by the before, we get x minus x naught is less than this distance, which is less than 1. But then, x, which equals to x minus x naught plus x naught, that becomes less than or equal to x minus x naught plus x naught, and then that's less than 1 plus x naught. So that's very good, because now this is constant, so we can just, this is less than constant, so we can just estimate this by 1 plus x naught. All right, so now we're ready for the actual proof. So now let epsilon be given. And let delta, again, to be the smaller one of the minimum, so the smaller one of 1, because here we assume it's less than 1. And also, so we want this to be less than epsilon over 2, so basically we choose epsilon over 2 times this term, 1 plus x naught. And also with this term, epsilon over 2 times, well, usually we want to put absolute value of y naught, but it might be 0. So just to make sure, let's add a 1 here. Okay, so this is our delta, quite complicated. But then, if the distance between all this, then if this thing is less than delta, then in particular this is true, so we can conclude that x minus x, that this absolute value of x is less than 1 plus absolute value of x naught. So f of xy minus f of x naught y naught. Again, just as before, we found that this is less than or equal to, what did we have? Absolute value of x, x minus x naught, plus absolute value of y naught times y minus y naught. Now, we know this is less than, at least less than or equal to 1 plus x naught, x minus x naught. And well, y naught is less than 1 plus y naught. Because the number is always less than 1 plus that number. And now witness the beauty of those choices. So in particular, what we know, x minus x naught is less than this distance, which is less than delta, which is less than that. So less than 1 plus x naught times epsilon over 2 times 1 plus x naught, which beautifully cancels out, and plus 1 plus y naught, epsilon over 2 times 1 plus y naught, again, which beautifully cancels out, and you get epsilon over 2 plus epsilon over 2, which is epsilon. And this is why multiplication is continuous. And it answers the question at the beginning, and last but not least, the ugliest of them all, let's show that division is continuous. And again, we'll do it raw. We will not use the fact that 1 over something is continuous. So, because again, it's good to see those things really from the beginning on, if you'd like. So claim 4, show that f, and again, remember, you can't divide by 0, so it's not r2, but it's r times r star. So without 0 to r, and f of x comma y is x divided by y is continuous. And again, let's do a little bit of scratch work. So f of xy minus f of x naught y naught, that is x over y minus x naught over y naught. And then putting this on a common denominator, that is xy naught minus x naught y over y naught. And this becomes the following. So now, again, let's add and subtract some terms. So let's do xy naught, if you want, minus xy, and then plus xy minus x naught y over y naught. And then let's use the triangle inequality. So that's less than or equal to xy naught minus xy over y naught, and then plus xy minus x naught y over y naught. But now again, we have a nice simplification. Here x factors out, and then here y factors out. It's the y factor, or the wow factor here. So we get x times, if you want, y minus y naught over y times y naught, and then plus y times x minus x naught over y times y naught. So that's a nice thing. The y's cancel out, and you're really left with, hope I won't forget about this, but you get x over y times y minus y naught over y naught plus x minus x naught over y naught. There are two parts here, one that's very good and one that's very bad. This part is good because we can control it, and this is constant. So the point is this we don't have to worry about. This part is very bad because this we can control, but now you have those two variables, which is horrible. However, we can use similar tricks to what we had before to study this, because suppose we have that the distance between xy and x naught y naught, if this is less than 1, then for sure we can say, at least for the numerator, that x, then remember in particular x minus x naught is less than 1, so x becomes x minus x naught plus x naught, which is less than or equal to x minus x naught plus x naught, and that's less than 1 plus x naught. So this is taken care of, but then the problem is for the y, we want something that's bigger than y, 1 over y. We want y to be bigger than a constant, because then 1 over y will be less than that. But now, here's the trick. Suppose now this distance, minus x naught y naught, is less than, you'll see why this is useful, y naught over 2. Then in particular, y minus y naught is less than y naught over 2. Okay. Now why is that useful? Well, remember the reverse triangle inequality. Y minus y naught is greater or equal to y minus y naught. And that's greater or equal, again, that's absolute value of the difference of absolute values. Do not confuse it with that. Like this. And that's greater or equal to minus y naught. Okay, absolute value of x is always greater or equal to minus x. And that becomes y naught minus y. And we know this is less than y naught over 2. So if you put this, so basically what we know, we have y naught minus y. It's less than y naught over 2. So if you put this y here and this y naught over 2 here, we get y. It's bigger than y naught over 2, which is good because then 1 over y, it's less than 2 over y naught. Okay, and now we can finally deal with this. So we finally got our good inequalities. We found that x is less than 1 plus x naught, and we found 1 over y is less than 2y naught. So let's just combine this. And we get, in general, so x over y, and let's say y minus y naught over y naught. So that's less than, first of all, 1 plus x naught, y minus y naught. And then also we have this thing, so over 2 times over y naught. But then remember, this is, we still have this 1 over y naught factor here. All right, and that simplifies to the following. So this becomes 2 times 1 plus x naught times y minus y naught over y naught squared. And what we want this to be less than epsilon over 2. Because we have two terms here, so let's make this less than. So let's make y minus y naught be less than, so epsilon over 2 times y naught squared over 2 times 1 plus x naught. Okay? And that becomes epsilon over 4 y naught squared over 1 plus x naught. Okay, very good. And now we're finally ready for the actual proof. So that was our motivation. And now let's do the proof. All right, and now let's do our actual proof with actually the correct thing. Whatever I said before might not have been completely correct, but let epsilon be given, let delta to be the smaller one of 1. That's the thing that allowed us to say x is less than x naught plus 1. Y naught over 2, that's what allowed us to estimate 1 over y. And then epsilon over 4, y naught squared over 1 plus x naught. That's what allowed us to estimate the first term. And then epsilon over 2 times y naught. That's what allowed us to estimate the second term. And then, if the distance between xy and x naught y naught is less than delta, then in particular, x minus y, so xy minus x naught y naught, is less than 1. And remember, we concluded from that absolute value of x is less than absolute value of x naught plus 1. Okay. And moreover, we also had xy minus x naught y naught is less than y naught over 2, which implies that, remember, 1 over y was less than 2 over y naught. And then let's estimate f of xy minus f of x naught y naught. And what we got was the following, I think x over y, and then, what was it? I think x, y naught, y minus y naught over y naught, okay, and plus x minus x naught over y naught. Hopefully that's the correct order, we'll see. And then, now let's use the fact that x is less than x naught plus 1. So this is less than or equal to x naught plus 1 times y minus y naught. But this is also less than 2 over y naught. So 2 over y naught times this extra factor of y naught. So 2 over y naught squared, and then plus x minus x naught times y naught. So in the end, you get exactly the factor that we want. So that becomes equals to 2 over y naught squared x naught plus 1 times y minus y naught plus x minus x naught over y naught. And then we get that this is less than 2 over y naught squared times x naught plus 1. And then epsilon over 4 times x naught plus 1 times y naught squared. Plus here epsilon over 2 y naught over y naught. And then you get finally the beautiful cancellation. This cancels out, this cancels out, this cancels out, and this becomes a 2. And then this and this cancels out, and you get epsilon over 2 plus epsilon over 2, which gives you epsilon. And therefore, division is continuous as well. All right, and now again, with confidence, you can say, well, 2.01 times 3.99 is roughly 2 times 4, you know. more or less, but really in your mind you're like, aha, because it's continuous. All right, I hope you like this, and if you want to see more math, please make sure to subscribe to my channel. Thank you very much.